Hey, what's up, my SDs? My SDs? People that are watching Mr. Myestis on YouTube. Here we go. This is the area between two curves, and I've actually got a couple of videos on area between two curves. This is for my BC Calculus class. I'm going to have two videos here, and one of them I'm going to show you to do these by hand without a calculator, and the other one I'm going to show you to do them on a calculator, okay? So this first one, let's take a look at the area between two curves. Remember that the integral, the definite integral, produces a signed area. It could be positive, negative, zero, or zero. What's zero? That's like Cheerios with all Z's. Maybe if you're asleep. Um, However, if you're ever looking for the actual area, then the actual area, it can't be negative, so you're gonna have to take the absolute value of that or something, okay? Sometimes you're asked to find the area between two curves. So what I've done is I've given you the formula here, and let me just to kind of explain what's going on, is that what we're doing is we're finding the area underneath f of x, right? So all this area, and then we're going to find the area zoom in here again. We'll find the area underneath f of x, okay? And then we'll find the area underneath g of x. And if we subtract those two areas, that's going to give us the area between. All right, and we're going to put those in. One integral. Okay, so I have this area here, the long one, which is the integral of a to b of f of x, subtract, and we're going to subtract the integral from a to b of g of x, and that's going to give us the area in between. All right, simple as that. So sometimes we have to go from y. We have to use dy, so we're going to go like up and down instead of left and right. So sometimes we have to do that. I'll show you an example of when we do in just a second. The basic idea here that you're going to need to make sure you remember is that you want to always go top curve minus bottom curve. Okay, so whatever's up here, so the bigger curve, the one that's above the other one, minus the bottom one. Or if you're you want to go right curve minus left curve. Let's take a look at an example. So here I have x squared plus 2. Okay, that's this one here. And then here I have y equals x. So what I'm going to do is this is the top curve, and this is the bottom curve. So I'm going to take my integral from 0 to 1 of x squared plus 2 minus x, because that's my second curve, dx. Okay, and that's it. So all I'm going to do is I'm going to solve that out now. So that's 1/3 x cubed plus 2x minus x squared evaluated from 0 to 1. So 1/3 1 cubed plus 2 times 1 minus 1 squared. Minus 0, but if I plug in the 0, if I plug in the 0, I'm just going to get 0. Okay. Oops, I forgot to divide this one by 2. Sorry, x squared over 2. All right, and then you know what? This is a good enough answer for us. We don't have to simplify on the AP exam, so we'll just leave it like that. But if you want to simplify, you can. Okay, let's take a look at another example. So I'm going to do one more example here for you, and then that's it for this video. Okay, so here I have the function here. X equals y squared minus 3. So this is actually a function of y. So that's going to look like, let's see, it's going to look like this. And then y equals x plus 1. Okay, 1 over 1. It's going to look like this. And I want to find the area in between. So this area here. Now, since this is in terms of x, we're gonna go vertically here. So we're gonna be doing the outer function, okay, the outer function, which is gonna be, what's the outer function here? That's going to be this one here. Okay. So we're gonna go this one here minus this one here. Could use, I guess I could use different colors. All right, so the rule that I said earlier is we want to go top curve minus bottom curve. And that's even if they're in the bottom, we still want to go top curve minus bottom curve, so that way it gives us a positive area. If we're going for functions of y, we're going to go right curve minus left curve. All right, so let's take a look. Which is the right curve? Not the wrong curve. The right curve. Okay, so the right curve is going to be the one on the right, which is this one here, and the left curve is going to be the at y squared minus 3. So I'm going to have the integral from whatever y value this is to whatever y value this is. I need to find where they intersect. Okay, so I'll get there in just a second. Let me just write down the inside part. Y minus 1, because I'm going to solve this. Subtract 1, x equals y minus 1. Y minus 1 minus y squared minus 3 dy. So I have to find the intersection here, guys. So I can't just leave it alone. Sometimes you have to find the intersection. So I'm going to go and find that by setting the two equal to one another. Y squared minus y minus 2 equals 0. Factor. And I get y equals negative 1, y equals positive 2. So my limits of integration are these right here. So I'm going to go from negative 1 to 2. All right, I'm going to simplify this guy out. So I'm going to end up with negative y squared plus y plus 2 dy, evaluated from negative 1 to 2. So that's going to give me negative y cubed over 3 plus y squared over 2 plus 2y evaluated from negative 1 to 2. Then I'm going to go and plug my values in. So negative 2 cubed over 3 plus 2 squared over 2 plus 2 times 2 minus negative 1 cubed over 3 plus negative 1 squared over 2 plus 2 times negative 1. And I'm going to go ahead and leave it like this. All right. Once I plug in my value, I can go ahead and leave that like that. If you wanted, you could simplify that more. Okay, so that is area between two curves. And again, if you struggle with this, that I went kind of fast, I do have another video. Just search in my YouTube page, YouTube channel, area between two curves, and I've got another video that I do a couple more examples in. Okay, so catch you later. Next time we'll do ones with using the calculator. See you guys. Bye.